Okay, thank you everyone for coming over again for these lightning talks. We are next having here Linux test project introduction by Cyril Hribis. Sorry for pronunciation of last time.
It was good enough. Okay, so hello, welcome to my introduction. So let's start. Well, there is some information about myself, and actually it made me feel a bit old when I realized that I've been using Linux for 18 years. I'm also working for SUSE for quite a lot of time, and I'm mostly working on kernel automation and stuff. And I've been LTP upstream developer for 2009, actually. So let's start with where it began. The Linux test project was founded by SGI, IBM, and these big companies in year 2000. And the picture there is a screenshot from Web Archive, because I wasn't around, obviously, because I was trying to install my first Linux at that time. And in 2001, apparently it contained 100 simple tests, syscall tests, and few test suites collected from other sources. Well, historically, LTP had quite a big problems and have had bad reputation until recently. It started to turn much better the last few years. But basically, there was no real manpower behind it. There was no code review. Basically, everything that compiled got in. And yeah, the build system was a mess. And it was quite problematic to even compile the stuff. And even when you compiled it, a fair amount of the test cases was failing randomly. So it wasn't really useful. And in SUSE, in the early times, we had to run it a few times and then filter out all the random failures. And yeah, it was kind of put together from different sources, sometimes crazy ones, because well, what I found out from the comments in the source code, that when IBM acquired some of the old proprietary Unixes, they just took their test cases and somehow ported it into the LTP. It was quite messy code, and they actually put inside everything they found out on the internet, so it was kind of Frankenstein, and sometimes even today the stitches are visible, but it's much better these days. And also one of the problems was that IBM tend to hire junior developers for the task, and it turns out if you want to test the kernel, you really need guys with some background into computer science and operating systems, and well, students wouldn't do, well, good job. So what we have done so far, we spent last few years working on the stuff, so now it's much more boring. We have adapted coding style, we have Git repository, we have code review and mailing list. We also, well, work with the GitHub, so we accept the pull requests there as well, and we do quarterly releases with these numbers of patches and developers that show per release. And we also use Travis for compile testing the stuff, so even things like cross-compilation, so it's quite nice because now if you take the latest LTP head, it will just compile just fine. And also, we make sure that the latest LTP is working on maintained distros. We basically, before we make a release, we try to compile and run it on everything we care for. Is our Red Hat, SUSE, Debian, and stuff like that. And we also have quite nice test libraries, so we do not duplicate code in the test cases. So if you are writing tests that needs something like block device or file system mounted at some point, you just flip a flag in the structure that is describing the test, and it's done. And we also have quite a lot of API documentation and tutorials. These are targeted mostly for people who want to write test cases, though. And here is the goal. It has been the same from the beginning. We are trying to kind of make sure that the Linux kernel and libc and related stuff works fine. We do not do any benchmarking. If you're looking into that, there is an excellent test suite from Mel Gorman. And there is also a test suite that's general test suite for file system. even if it's called XFS test, that's kind of historical name and nobody bothers to rename it at this point. So if you are looking for testing file system, you should combine LTP with that one as well. So what are the challenges? Well, the biggest challenge is that the project goal is quite broad, and there is obvious disparity between the number of developers that develop Linux kernel libc and LTP. It's kind of problematic because they keep to add syscalls and stuff into kernel, and we are still trying to catch up on that. Well, and it's even difficult to estimate how much user space API is there. If you ever seen the excellent book from Michael Karisk, the Linux programming handbook or something, it's not, I would say that it's not even half of it. Nobody really knows what's there. And LTP is, well, kind of large, and it's mostly complicated low-level code, so it's a challenge as well. And sometimes there is not even documentation for the kernel interfaces, and when it is, it may be wrong. So I ended up with quite a few patches in manual pages as well when I was fixing the test cases, because sometimes I just found out that the main page is saying something different than the code in the kernel is doing. And also, sometimes the kernel API really changes, because if you ever seen Linux shouting, we do not break the user space on mailing list, what it really means that they would not change any code that is used by user space programs. But it turns out sometimes there is some interface that is really used by just the test cases. In such cases, it does not make much sense to keep it if it's broken. So sometimes they break out test, and we have to deal with that. Okay, what's really inside? We do have quite a lot of syscalls test cases. These are mostly unit tests for the syscalls, so they call the syscall and check that it's doing something reasonable. We also feed it invalid inputs and check that it returns some reasonable errors. And then there are some more complicated stuff, but these are mostly unit tests. Then we have a fork of the open POSIX conformance test suite. It was developed separately, but the upstream is dead, so we carried on. And we have started to add various regression tests for Linux CVs. This is quite recent, and we have, well, not that much, but quite a number of these now, even the most important ones. And then we have I/O stress test, network-related test cases that needs 2 machines, and real-time test suites, and various containers and namespaces and stuff. Okay, what are the design goals? We are really trying to keep it simple. So the languages of choice are C, and each test is unexecutable, it's self-contained, it runs automatically, and the status is passed an exit value. We are just trying to make stuff sane and easy to use. Well, and this is the question I'm getting quite a lot, and people are asking, well, do we really have to test our kernels when the upstream is tested quite a lot? And it turns out, well, when you take the upstream kernel and you start applying patches, you will break it sooner or later. So you really should test that. Well, and there is a short how-to. I'm just trying to tell you that it's really easy to use LTP these days. So if you want to run an LTP test case, you just have to download the code and then just compile it. Then you can run most of the test cases directly from the source code directory. Some of them need a path to the current directory in the path so they can execute sub-executables. And the shell test cases need a path to the shell library in path, obviously, but that should be it for most of the tests. Or you can really install it and use the script that sets up the variables and stuff itself. Well, the solution that we have in the LTP is quite dated. It works, but I want to work on replacement, so it's much easier to integrate it into the modern frameworks, because this one just it's a shell script that runs kind of old binary, and it produces well, text files that are parsable, but I want to have something that outputs JSON and XML stuff. So you just plug in that thing into modern CI, it just works. Well, we also have scripts that run the network test cases, and these are, some of them are basic, some of them are quite advanced. You can either set up two machines with the same LTP installation, and one of them will SSH to the second one and run the network stuff between them, or it can also fall back to namespaces, so you can run the network stuff on single machine as well. Well, and that's about it. There are links to the repository, mailing list, wiki, and IRC. So let's go to the question if anyone has some.
Yes, there's a question over there.
So what would you say, how stable is that today if you run that? Are you still having lots of false positives? Classification maybe of tests that are stable and tests that are
Basically today, if we run it, they are asking about the stability of the test cases. These days, when you execute it, sometimes one of the tests may fail and it may be false positive, but we have thousands of test cases, so I would say we are pretty good. We spent something like last 6 years working on that.
Yeah, there's another question.
you voted for test your own kernels. Okay, if I do that, and some test cases fail, what do I do?
Well,
Do you collect these failed tests?
you can write to the mailing list. People do that from time to time, asking about, hey, this fails and what I'm supposed to do, and somebody will, mostly me, will look into that. Actually, it's these days it's used on the 0-day thingy in Intel, so you will probably not catch that much of the bugs because the automatic framework usually catches them before it gets even to the main line. But yes, you can always talk to us on the mailing list on IRC. I'm on the IRC at least during my work time. So,
But the result, if people follow your advice to test their own kernel, you will be flooded with messages because you always find some cases which fail on a particular machine because of some exotic PCI SSD, for example.
well, the question is if we will be flooded with messages, and the answer is we do not test much of the driver-specific stuff yet, and I'm not sure we will have manpower for that, so I'm pretty sure that we will not be flooded that much because most of the generic problems will show up everywhere. And we are running it also into automatic frameworks in SUSE. We are using OpenQA to run the stuff, and it's executed well daily. So